Well, it is that time. So it is my pleasure to introduce our next session, AI Agents and Agentic Frameworks, an overview. Agentic AI represents a significant advancement in artificial intelligence, characterized by its enhanced autonomy, decision-making capabilities, and adaptability. Here to give us an overview of AI agents and agentic frameworks is Frank Brockners. Frank, it's all yours.
Jen, thank you so much. So, we're going to go and talk a little bit about agentic frameworks. Going to go and highlight a few, and also going to try to give you a little bit of an advice on where you might want to go and start and where you might want to go and end up if you want to go and build mature systems. I'm Frank Brockners, and I did this work together with Rinaldo Penno, a friend and colleague of mine, and I'm part of the Outshift organization inside Cisco. So let's start off with this. What is agentic AI? Jen talked about that in 2 sentences, and maybe I spend a little bit more time on that. So first, what is an agent? And what I really like is there's a very simple definition that the LangChain people came up with. And the LangChain people said, well, we define an agent as a system that uses an LLM to decide the control flow of an application. So it's not only question answering, but it's deciding on what to do and what to do next. Very simple definition and pretty useful. And the LangChain people also came up with saying, okay, like I can go and group this into multiple levels of autonomy that I have with agency. So you start off with level 0, pretty much like the automotive industry does it, right? Where level 0 is everything is human-driven, i.e. the output of a step is human-driven, or code that a human did. Deciding on what next step to take is driven by the human, and also which steps are available is driven by a human. And then you go multiple layers, right? So if the outcome of an LLM call is the first level of like something autonomy, okay, we call that level 2. If we are chaining multiple outcomes of an LLM call, so like chain of thought, tree of thought, we call that level 3. And if we are having an LLM already deciding which steps to take, like which tool to call, we're calling that level 3. And the minute we go in cycles, where we're having an LLM kind of saying, okay, I continue the investigation, or I stop an investigation, then we call this more like agent executed. So we are reaching real levels of autonomy, because then we have a state machine controlled by the agent as opposed to the state machine of the overall system controlled by the human. And full autonomy means like you decide on the steps, that the outcome of the steps is an LLM, which steps to take is an LLM, and which steps are even available to it would be the choice of an LLM. You can argue what is agentic forever. And it's a relatively boring conversation, and Andrew Ng coined it very nicely. He said, well, what is not agentic if it's simply you asking an LLM and something comes back. But if you're engaging one or multiple LLMs into decision making, into a process, be it stateful, be it half stateful, let's call this agentic and move on, rather than arguing over the definition of agentic, because you can go and keep your entire day busy doing that. So let's use an example between what is clearly not agentic and what is really agentic. And again, I'm using an example from Andrew Ng, and I think he really nailed it with that very simple example. So let's assume we want to go and write an essay. And what we are asking LLMs to do today is, you ask an LLM, go and write an essay on that particular topic without using backspace. Is that fair? Even to a human? Not really, right? And yeah, you can argue, what is the quality of this outcome? Maybe it's good, maybe it's not so good, but typically it's not so great because you don't really allow this thing to think. You don't allow this thing to self-correct. So what is the better way to go and write an essay? Maybe we do this in a collaborative way, right? Where you say, well, this is the title of the essay. Then you do research on the web to go and find information for her title. So you created the outline, you gather information, you write the first draft, then you're critiquing the draft, then he's going to write a second version of the draft, and we iterate over. So which essay is going to be better? Me writing an essay without using backspace, or 6 of us collaborating, right? So this, like, write an essay, write an outline, do web research, and iterate. And what we found is that LLMs, much like humans, are very good at critiquing something. Actually, sometimes they are better at critiquing than at creating. Again, humans are kind of plugging a hole in, so something is way easier than really coming up with a better version. So that the thinking about things, revising things in an iterative way, that's clearly agentic. Why is this useful? Agents are, or agentic behavior allows us to increase the level of accuracy of our outcome dramatically, much like human teams. If we are on our own and we need to go and do it single shot, like GPT 3.5 is a not so great model, and this is like mostly coding benchmarks. For coding benchmarks, GPT 3.5, you probably remember, if you ask it a coding question, the outcome is so-so, like 50% accuracy roundabout. But research has shown that if you use agentic behavior, i.e. propose, critique, iterate, you can push it all the way to 95%. So even a so-so model can perform super well. And the same is obviously true for more mature models like GPT-4. So agentic behavior is pretty much like humans organized in a team, where the team will always outperform what an individual human can go and do. So what are the typical design patterns of agentic systems? The first thing is, like when we wrote our essay, we created a plan. What do we want to go and do? And then we decided, like, we need to go and use a couple of helper functions, tools, search the web, look at YouTube videos, write some code in order to answer my question. That's tool calling. Reflection, or like critiquing what I created, is another asset of agentic systems. And obviously, multiple agents need to go and collaborate. And then there is a final thing. Much like humans, it's very boring to talk to a person that does not remember a word. Like, you sometimes know this from very old people that tend to forget what they just said, right? And it's pretty tedious to talk to these people. For agents, the same is true, right? If you continue to go and have to tell the guy, you need to know this and this and this, it's way better if they build up state and history and they memorize earlier examples so that they can learn from the past. Again, much like humans. The whole thing is on, and it's getting hotter every day. So we started off with large language models, but kind of the hotness in the industry transpired all the way into agentic behavior in the last 6 to 12 months. So there went 20 billion went into agentic kind of startups in that area, and Gen AI, and that thing is only ramping. And Gartner believes that in the next 4 years, that at least 15% of all the people will work daily with autonomous decision-making using agentic AI. I think 15% is a very low number by now. And this whole thing is crazy, right? If you look at OpenAI releases, and I plotted this thing like as of like end of May, so as close as I could get to the show, OpenAI releases almost on a weekly basis. So there is new stuff coming out on a weekly basis. And it's not only OpenAI. Some of the kind of pretty well-known frameworks for agentic behavior, LangGraph, they are doing the same. So it's not that the basic tool set is moving really quickly. Also, the guys that are consuming the tool set and bringing that into agentic environments, they are keeping up with that pace. Weekly. Imagine you get a new router release every week. That's the pace that the industry is moving at right now, really quickly. Many of you probably use agentic behavior, and that's from a report that LangChain did last year, which is why some of the things that are really hot today are not even on here. But what they found as the most commonly used agentic AI application is Cursor. So your coding IDE. Or Perplexity on place number 2, your, well, famous question and answering machine. Or Replit as your very quick Gen AI supporting front-end prototyping engine. If you want to take a picture of that, here you are. You got it? Excellent. You can also download the slides, right? So they're all available. So what do people use agents for? And again, data from LangChain, research and summarization, obvious, we all do this. Personal assistant productivity. One thing that is pretty high up here is customer service, and that's something that I work on personally. Because what is Gen AI's key nature? It gives software a human interface, natural language. And that means I can translate things that humans do into software. Or I can even replace humans with software wherever you need a natural interface. Systems level integration, troubleshooting, across multiple domains. Whenever you needed humans in the room or human decision making, well, this is high up because LLMs allow us to go and help us in that area. What is the key concern with agentic systems? Performance and quality being number one. Because like, yeah, you're handing this thing off to something that has probabilistic behavior. Like to a human, right? So you're handing a task off to somebody that might do something, hopefully the way you instructed him or her. The same happens here, and getting agentic systems to go and do a nice demo is easy. Getting agentic systems to behave deterministic in a production level environment is quite hard because the underlying system is probabilistic, right? Cost, other concerns, but this is the number one. There are some historic parallels, and you see I have a little bit of gray hair, so I lived through a few of them. It feels a little bit like in the early 80s, where I tended to learn a new programming language every few months. Remember things like Pascal, Logo, Modular 2, all gone. They all had their time, basic, whatever. In the times of the internet, it was the same thing. The early 90s, FTDI, Token Ring, X25, anybody remembers, right? So, of course, like whenever you have gray hair, you remember, I know. So this is like the same thing happens right now. It's a little bit like crazy mode, or my boss calls it insane mode, where new stuff happens almost on a daily basis, and the industry hasn't completely settled yet. So let me go and touch base and look at a few of the frameworks that are out there. What does an agentic AI framework really offer to us? It helps us, first of all, with prompt engineering. So you no longer, if you need to go and build agent-to-agent communication and wire certain things up manually, it's all about prompt engineering. Tell the agent, maybe in the system prompt, exactly what you want, and then tell it like the outcome needs to be JSON, pure JSON and only JSON and no rubbish around it so that it can easily parse it. Here is a structure. And then you also told it as part of the system prompt, you are following the following chain of thought pattern. So you could go and do all of that yourself. But it's relatively error prone. So let's delegate it to people that know that better. Agent abstractions is the first thing that all these agents started to go and do, so that we have interaction models that are well defined. So the system prompt underneath is what these guys help us with. Tool integration, similarly. And also the planning and deep composition phase, like how do you build a workflow? So that's the first part of the thing. And the second thing is it helps us with operating agent ensembles. How do you deal with memory? How do you deal with additional context? How do you orchestrate the whole thing? And more importantly, how do you trace, log, and debug these systems? Because the minute you have these systems working, fine. But sometimes they break, and then you need to understand why they break. And again, like you're having multiples, and this is from a blogger here. Some people believe they can do without, fine. But if you don't do without, there is a choice that you need to make, and that choice is between simplicity, and you're handing off control, and control, but if you have control, you need to execute control. So it might be easy, but you don't know what's going on, and that's good for demo. It might not be that easy, but you're in control, so you know what's going on, and you can troubleshoot accordingly. So that's the balance that we need to go and typically cut. And there are a few frameworks out there, and they all have their different areas of focus. I want to go and call out one before I really dive in. So DSPy, that's a Stanford initiative. They are relatively specific because they drove prompt engineering all the way to the very end, that you compile prompts. So they're really trying to go and optimize prompts at a system level without human behavior, but they're building an objective function to optimize the prompt for a particular task. So this is how far you can go and drive prompt engineering. If we want to go and look at the various qualities, what they offer is different vehicles to go and communicate between individual agents, the different use of models. Not every framework supports every LLM out there. The different types of agents, as I said, you can go and give these agents roles. You're just a chat completion agent, you're a code execution agent, you're a file server agent, human-in-the-loop behavior, how agents team up. Do I do a round robin? Orchestration, how I can go and put things into a workflow, how I manage state and memory so that you have systems that you can go and farm off the learnings into a vector DB and retrieve that in future operations. And finally, like the ease of getting onto it, like how quickly can you learn it. And I want to go and focus on 5 of them really quickly. Swarm from OpenAI, because it's from OpenAI, you can't ignore it. Autogen, one of the oldest ones, easy. Also CrewAI, also relatively old as in 2 years. Semantic Kernel, also started from Microsoft, and LangGraph from LangChain. So let's start off with Swarm. Who knows the Assistant API in OpenAI? Quite a few. So the Assistant API is you hand off a task, you give it a couple of tools, and it's a stateful agent. It decides things on itself. It might call a couple of tools. This was an experiment to experiment with stateless behavior, first of all. And secondly, decide on what the next step might be in what they call handoff. So they have agent abstractions, but the main experiment was to have a handoff so that I can start off something, and then I'm doing this hot potato routing. Like, I'm not completely done with it. I hand it to you. You might do something, then you hand it to her, and so forth. So that, like here, what's the weather? Well, I don't really know what the weather is, but I know who to call to go and get the weather. So it's almost like tool calling, but you're handing it off. You're not getting a return, but you're handing off to somebody that might be able to go and resolve the thing for you. And this transpired as a concept into a framework that Microsoft built, Autogen. That's one of the oldest ones. It's been built by Microsoft Research, and it's very complete by now. It's to build agentic systems, and it offers a load of capability to go and have plug-and-play capability. So they define multiple agent roles. A coder agent or a code execution agent, a chat completion agent, an OpenAI chat completion agent, a file server agent, a web server agent, a video server agent. So all kinds of agents, human-in-the-loop agents, they're all predefined. They have interaction patterns that they predefined. And they allow you to, because these agents can go and do stuff on their own, they can go wild. It allows you to go and control a load of the hyperparameters. So how many tokens should they go and consume? How many tokens from the request string should they actually use? So you can go and tweak variables like the token mask, like top P. You're able to go and tweak a load of the hyperparameters in order to go and keep the agents under control. They have teachability and personalization, so they are able to memorize what you go and told them, and it's further extensible. So if you want to have something easy to start off, there's a load of templates available. Autogen is a relatively easy choice, but there's one kind of caveat. They used to be tightly stringed to the OpenAI and Azure OpenAI LLMs that are provided. And yes, you saw this, is underneath, there is a load of prompt engineering happening. And you know as much as I that the prompt for an OpenAI call is not the prompt for an Anthropic call, right? So Claude has a slightly different nomenclature, and the prompt for Claude might not be that well with GPT-4. So they started in that corner. They recently adopted Ollama so that you can have self-hosted models. They recently adopted Gemini, and they recently adopted Anthropic. Bedrock, still not there. But there's some gravity towards this Azure family. If you don't like that, the other very simple framework is Crew AI. And Crew AI underneath, so it's very similar concepts. Crew AI uses Light LLM as an LLM abstraction, and that way they're able to rope in a wide variety of LLMs for that. Crew started off with defining crews that are almost open-ended collaboration. So you're handing off stuff to a crew, and then the crew will operate, which is great for something like a research task, web research, web crawling, and try to go and figure out, like, I want to go and learn about more about, like, whatever, quantum research, and then it heads off and does something for you. For those open-ended tasks, a crew will operate quite well. If you want to have a more of a defined outcome where you really say, well, this agent needs to go and do this and hand over to this, and so you're having more of a workflow structure, they came up with what they call flows. But these flows are relatively simplistic in being either hierarchical or sequential. So they're starting to go and be like not completely wild, but also controlled with this flow capability. But still, the framework is very simple. Was started by two gentlemen from Brazil. And if you look at the global kind of adoption, Brazil is still the country where Crew AI is leading the pack for over everything else. So people have a little bit of like nationalism even when it comes to agentic frameworks. Semantic Kernel, that's the other effort by Microsoft. And Semantic Kernel was started off as a way where you have a code blob and you want to go and attach some agency to it. So not like you starting off with, I want to go and try an agentic application, but I have something where I want to go and then hand off certain things, maybe a decision point, to an agent instead of a human needs to go and do that. This is where Semantic Kernel started off from, and then over time, they grew and they started to go and have planner, memory integration, orchestration capabilities. So they're expanding, but they're still like not as easy to consume as, for instance, Autogen. There's only two types of agents defined: a chat completion agent and an OpenAI chat completion agent. So all these other kind of templating that you see, like with an Autogen, it's not here. So it's a little bit lower level. It's more like we're moving towards from easy, you see that, we're moving from easy more towards more control over time. And by the way, like you wonder, like what Microsoft does is left hand not talking to right hand, left hand talks to right hand. That in March they announced that they're starting to use the same runtime between Autogen and the semantic kernel. So that the things are coming together, and from in Autogen you can also call semantic kernel functions. So it's coming together. Final thing, if you run more of a production level system, you typically end up at the end of the day building something with a framework that allows for relatively granular control of what you're doing. And that is what LangGraph offers you. In LangGraph, everything is a workflow. So everything is mapped onto a graph where you can have individual agents call each other, and then you have decisions points, like do I branch off, do I iterate. That gives you a highly defined interaction structure, but that also means you have to go and define that interaction structure yourself. You have to control it, but you can trace through this, obviously. You can ask, where am I? And even if I go through multiple circles, they accumulate memory over these multiple iterations that you go, and I can even change the state of these iterations manually. So I can manipulate the agent memory. That allows me to time travel. I can forget selectively. I can manipulate kind of what you have in your memory. So everything is graph-based. This was inspired by Apache Pregel, so a Google Pregel a project that they started, I think, in 2013. Very granular state management, very granular memory management. And if you're building multi-agent applications, you typically end up building something with LangGraph. So from a usability perspective, you can actually see that with GitHub stars. So people typically give stars if they like something. It's like the thumbs up button, right? And from a GitHub stars perspective, it's clearly that this is Autogen and this is Crew that are leading the pack. If you look at Google trends, what people really Google for, then LangGraph is way ahead of everything else. So that just means like figuring stuff out in LangGraph, most of the people look for. So this is the production level thingy. This is like getting started quickly thingy. And that's clearly like transpiring even through the stats. So if you want to go and have something easy, write a demo application, get used to agentic behavior, start with Autogen or Crew. If you are pretty mature, you pretty much end up with a control framework. And it's maybe LangGraph, could also be Agentic AI. There's a few other relatively low-level frameworks that allow for that. So there's no one-size-fits-all. And I think I pretty much covered that. One quote from Harrison Chase, and I want to go and drill a little bit deeper into that, is if I'm building stuff for real, I need a reliable orchestration layer that allows me to fine-grain control what my system does. And typically also end up defining agents that are having relatively small and very contained tasks so that they are easy to control, that the outcome is understood, and that you can go and cope with that outcome. So one key aspect is the memory management of this. And there's multiple levels of memory management. So if you look at this cognitive architecture of language agents, this Koala paper, these guys defined multiple levels of memory. Like there is topic knowledge, so stuff that you learned. There is episodic memory, that's your experience. And there is procedural memory, like the rule sets, the law that you have in that system. All of that transpires into the agentic world. And then you have this at two levels. One is stuff that goes into your context window as you're running through a system, right? So you're iterating, and an agent learns something, and it's accumulating that state in the context window. But there is stuff that you learn through a cycle or multiple cycles or through a complete program run that you want to go and farm off, that you want to go and keep for later. That's what you call long-term memory. And the systems all supply for some function to go and do that. You typically put that into some backend database so that you can retrieve it with a particular index. So it's a backend vector DB that you use so that you can later on do retrieval augmented generation against that vector DB. But what goes into long-term memory is also non-trivial. So imagine like you're debugging a particular case, and today you debug that particular case in a lab environment. And in that lab environment, you may be not concerned about security. If you move into production tomorrow, you didn't want this guy to go and forget about the security problem that you had in your lab environment, despite the fact you were safely to ignore it. But if you move into production, it suddenly becomes important, or the other way around, right? What is important in production might not matter in the lab environment. So teaching an agent to go and do that is non-trivial, right? So what to memorize is an important thing. Let me go and give you an example what you can go and do with granular management of memory. And let's go back to our essay that we wrote before. And we're starting off, and this is an example of Harrison Chase and Andrew Ang. You can look at this example in a deep learning course that they have. So we have a planner, and that planner said, we are an expert writer. You're tasked with writing the high-level outline. Then you have a web researcher. Can we stop that? Then we have a web researcher charged with providing information. Then we have one guy that first writes a first draft. Not sure. Could you stop that? That's probably why somebody unplugged it last time. So we write the first draft. Then we have somebody that is a teacher that reflects on the first draft. Then we have somebody that takes this critique from the teacher and researches again, and then we regenerate. And we go into a couple of cycles. So let me show you an example. And I say, well, your topic of research or essay is Amsterdam. And then we're running through this. We're going from planning to research to generate to reflect. So I'm fast forwarding here. And at some point, after 3 iterations, we stop. And I can go and look at the overall history, what this guy did. Planner, research, generate. It reflected, it researched again, it generated again, it reflected, research, critique. So we're at that draft. So 3 cycles we went through, and then we can go and look at what it did as a plan. Brief overview of Amsterdam. We could look at what it retrieved, and we used Tavili to go and retrieve that information. We could look at the draft that it created after 3 iterations, like Amsterdam, a city renowned for its unique beauty and blah, blah, blah. We can look at what the teacher created as a critique. So all of that is there. Now let's go and play a little bit around with that agent memory. Let's go and put another topic, like say, well, let's go and write a topic about Cisco Hypershield. And this time I'm stopping right after the planning phase. So I'm asking the thing not to go any further than the planner. So went through the planning phase, and I can go and now look at the plan, go and refresh here, clean up. So a brief introduction to Cisco Hypershield, that's my plan that I want to go and do. And from a research perspective, you see that's empty now, right? Because I stopped right after the planner. Now I do something, I'm looking at the state, so at the inherent memory, and it says like, here is a brief introduction into Hypershield. That's what I captured there. And now I'm doing something crazy. I'm changing the plan manually. And I say, well, discuss the importance of time warp for Hypershield. Complete bollocks. But you know, these guys are able to go and deal with that. So we saw that here, now the internal memory also got changed to the importance of time warp for Hypershield. And now I'm passing through and say, well, let's go all the way to the generate phase so that we get a generated plan. And if I run through this, and I then start to go and look at my draft, you see that time warp in the context of Hypershield, indeed, it came up with something. Funny. I don't like that, right? Because it created something strange. I can now time travel. I can go back to the agent and look at my history and delete all that history and go back to my original plan. So if I refresh here again, it's my original plan, and I can carry on from that. And then it will come up with something meaningful about Amsterdam again. But what did that teach us? If I'm troubleshooting, right, you sometimes know, like, I looked at the network interface and I thought, like, it might be an error on the interface. I don't want to go back to square one. My application doesn't work. I might now need to look at another router nearby, right? So I need to go and time travel back a little bit. Like, we humans do this all the time. Agents need to go and do the same thing, which requires granular control over what you have as memory in the system. So, a few closing thoughts. I like frameworks because they help me get stuff done faster. I could go and code everything up myself, but then the error handling, the prompt engineering, everything is on myself. So use the templates that are there and use the tools that are there, because we learn from the industry, like over time things will abstract and they will mature and they become debuggable. There's a load of stuff going on unified agentic architecture, self-optimizing agents, fault tolerance is a big topic, security, reputation. One big topic that we are working on as Outshift, as an incubation team inside Cisco, is how about you have multiple agents in multiple places? That means we're suddenly building an internet of agents. So you need to go and then discover these agents. You need to understand, are they secure? What is their reputation? How do I connect to them? How do I observe them? How do I secure the connection? So all the stuff that we do as networkers, we will need to go and do again for agents. And we thought that we're not going to go do this alone. We created an open source project back in March. The so-called agency, and the misspelling of this is intentional, that was marketing people. So agntcy.org. It's an open source initiative to go and solve all these problems around agent discovery, agent connectivity, agent observability, agent security as a collective, because we as the industry have to agree on that. If we just do that in a corner, it wouldn't help us. And obviously, it's not about technology alone. It's also about like building multiple disciplinary expertise. So it's all on us. Agents are good, but there's still the human in the loop all the time. Thank you so much.